So yesterday, last time, we looked at kind of the idea of a mole and really how what it told us about like number of atoms or molecules of a substance. Today we're going to be looking at what do moles tell us about the mass of a substance. So we're going to make use of the average atomic mass located on the periodic table. That's why that's there. So if I look at hydrogen, it looks like it has an average atomic mass of 1.0079. And we would say, that's 1.0079, atomic mass units, well over 99% of all hydrogen atoms had a mass of 1, but there were a couple that had like 2 or 3. So what that means for us with the mole is like, why did they pick 6.02 times 10 to the 23rd to be how many atoms are in a mole? Really, it comes down to that's how many atoms it takes. So for hydrogen, if I had 6.02 times 10 to the 23rd atoms of hydrogen, that would give me a mass of hydrogen of 1 gram. Really, that's how many atoms it takes to go from atomic mass units to grams. All right, so we're going to add two more things here. So we're going to add a box for mass over here. And we can go from moles to mass and from mass to moles. All right, so let's say that we're given moles and we need to find mass. What I'm going to do, okay, so if I'm starting with moles, that means 1 mole will need to go there. What I'm going to put on the top is molar mass. And that's going to have a unit of grams, okay? So down here at the bottom, if you guess, here we just kind of flipped it. So if I start with mass and I need to find with moles, that means I need to end with 1 mole on top. But molar mass will be going on the bottom here. And once again, that'll be in grams. So let's actually make use of this. Okay, so this one, write it down quick, pause it, write it down, and then I'm going to scroll down so I can actually show you kind of how this works. All right, so let's say that I have 3 moles of boron atoms. So boron's right here. And I want to know what mass of boron do I have, or how many grams of boron do I have? Keep in mind, we're pretty much leaving off the of here. So really what we do is start off by writing what we know. So 3 moles of boron. Chances are I'm converting, so I'm going to need something like that. So if I'm starting from moles of boron and need to go to mass, I'm going to use this conversion here, where I have molar mass on top, 1 mole on the bottom. Okay? That means I'm going to have 1 mole of boron on the bottom. That way moles of boron will cancel. Now here I'm going to come and I'm going to see 1 mole of boron has a mass of 10.811 grams. Okay, so I'm just going to write that down. I'm not going to round that all. So 1 mole of boron has a mass of 10.811 grams of boron. Okay, moles of boron's top here, moles of boron's the bottom there. Cancel out. So this one I'm going to take. Ooh, that's bad. So in this case, I'm going to take 3 times 10.811. So get out my trusty Windows calculator here. Mainly because it's the one that I have. 3 times 10.811. 32.433. And once again, I'm left with grams of boron per unit. So that's my unit there. Okay, so 3 moles of boron have a mass of 32.433 grams. I think that would be really easy for us to measure kind of at our level. Like our electronic scales, even in our lab, would be able to measure that. Let's look at something slightly different. Let's say that I have 85 grams of O2, okay, oxygen gas, 85 grams. And I want to know how many grams of O2 do I have. So the first thing I need to do is I need to look here, and I'm going to see let's just figure out what the molar mass of O2 is. So the mass of one oxygen is 15.999. But in this case, I've got two oxygens there, so I'll need to take that mass times 2. So let me bring this over. 15.999 times 2, 31.998. I'm going to be honest, you could probably get away with just rounding this one, but let's just try it out. All right. And our question is not grams. We want to know how many moles of oxygen that is. All right. So I know at some point, doesn't matter which way I'm going here, if I'm going from moles to mass or mass to moles, I need the molar mass. All right. So in this case, first step, write down what you know, 85 grams of O2 times my conversion. Chances are if I'm starting with grams of O2, I want to end with moles of O2. I need to put 1 mole of O2 up top. And we figured out the molar mass of O2 was 31.998 grams of O2. Make sure I'm doing that right. Grams of O2 on top, grams of O2 on the bottom. So really what I have this is I have 85 times 1 divided by 31.998, or 85 divided by 31.998. Bring this over. 85 divided by 31.998. Looks like we're working with 2.6, let's call that 2.66 moles of O2. All right, keep in mind when you're doing this, I need to see this math right here. I need to know what we have grams of. I need to know what the molar mass is and what's it of. I want to know what we're looking for moles of as well. Mainly because this unit analysis becomes really, it'll make it really, really easy when we move on to something that's quite a bit harder. Like next time when we go from 4 millunits to mass. But until then, happy practice, and we'll see you next time.